Part D. If C satisfies the conclusion of the mean value theorem for f of x on the interval from 4 to 7, then find all values of C. So remember, mean value theorem is basically when the derivative of f of x, and it's usually written as derivative of f of C, that's what we're trying to find, is equal to f of b minus f of a all over b minus a. So basically, we're looking at when the derivative is equal to the average rate of change, right, or the average slope. We're finding the slope between the endpoints. That is our average rate of change. We want to find out any points where the derivative equals that. So C has to be some number in between 4 and 7. So what we have here, we've got derivative of f of C equals, in this case, we're doing f of 7 minus f of 4. So that's e to the cosine of 7 minus e to the cosine of 4 all over 7 minus 4, so all over 3. So basically, we want to know when is the derivative equal to this. What we can do is graph two things. We can graph this as our y sub 1, which we should already have, I think, right? And we're going to graph this as our y sub 2. We don't need that old y sub 2 that we had in there. This is just going to be a constant, right? But it's just going to be a horizontal line. We want to basically figure out when do these two intersect each other. So if we go to y equals, we already have the e to the cosine of x. And for this one, actually, I take that back. We have to graph the derivative of that. So our y sub 2, I'm going to go up there, turn off the y sub 1. Our y sub 2 is going to be the derivative. So we're going to do math 8. We're doing the derivative in terms of x of y sub 1. Oops. And we're doing that in terms of x. So we're going to graph the derivative, and we're going to graph that e to the cosine of 7 minus e to the cosine of 4, all divided by 3. So I'm going to put parentheses around that numerator. Oops. So all of that divided by 3. There we go. It should. What's that? Something's not looking right here. Oh, there it is. Okay. All right, and we're looking at this from 4 to 7, so we want to change our window, which of course is going to mean we're going to have to watch a graph again. We're going to go from x min of 4 to x max of 7. So we get to watch the slow graph a little bit more.
Are you going to work on? Oh, yes. Yeah,
Right, so we should eventually get 2 intersection points here. So that means on that interval, the derivative is equal to that average rate of change twice at 2 points, right here and here. We can calculate those using second trace, intersect. So we can move our cursor closer to this side over here, enter, enter, and enter. And we get 4.591. Oh, I take that back. Just changed on me. 4.202 is our first one. And for our other one, second, trace, intersect. Yes. Oh, now you got me mixed up. All right, and then we get 6.081. Should be our two answers.